we go. So, I've already done last period. I've already done 45, 47, 89, and 90. So I've already done those. So don't ask me those. And if we get to a point where there's no questions, you guys can just work on the review sheets and we can call it a day. So I've done 45, I've done 47, I've done 89, and I've done 90. That will be posted on Google Classroom next period. So what other questions do you have besides those? Yes?
Wait, let me open up my homework. I do have one.
Adrian, what's your question?
Did you do 67?
I did not do 67.
Okay, let's do 67.
67. Here we go. Yes. Here we go. All right. You can use that.
What about this pink one?
You can also use that. Whatever brings you joy is what matters. All right, 67 says the following. A 100 milliliter aliquot, which is such a fun word to say, of 0.2 molar aqueous potassium hydroxide is mixed with 100 milliliters of 0.2 molar aqueous magnesium nitrate. A, write a balanced chemical equation. Here we go. So 67A is a balanced equation. So potassium hydroxide is KOH. That says that it is aqueous. Plus magnesium nitrate. We know that is MgNO3 parentheses 2. That is aqueous. That is going to give me KNO3, which we know that nitrate salts are aqueous, plus MgOH parentheses 2. And if you look at the back of your blue periodic table, it says hydroxides are not soluble, so that is your precipitate. To balance it, 2 OHs here. I've got to put a 2 here, which means I have to put a 2 here. I already have 2 there. That's balanced. So that is part A of 67. Part B, what precipitate forms? We've already identified it. It's magnesium hydroxide. So that is B. Questions so far? Yes?
What does the down arrow mean again?
That's what goes at the bottom. If it was in a test tube, that's the solid.
Oh, okay.
So it's the precipitate. So that's A, that's B. C, what mass of precipitate is formed? So now what do I have to do? Determine the limiting reactant, and then whichever one it is, that's the one that makes the mass, right? So on 67, they gave me 100 milliliters of KOH. Are you guys okay with that being 0.1 liter of KOH? Yes? And we know for every 1 liter of KOH, they said we get 0.2 moles of KOH. Oh, hold on. Oh, well, I guess we still have to do this. Still have to do it. And then for 1 mole of KOH, what is the molar mass of potassium hydroxide? Everybody got it? On your work? Nobody? It's 58.33 grams of KOH. So when you solve for that, you end up with 0.583. Oh, wait, I don't even need to go to moles. I should have just stopped at moles. Let's just do it with the moles. So 0.1 times 0.2, let's stop there. That saves us work. 0.1 times 0.2, it's going to be 0.02, right? So that gives me 0.02 moles of KOH. Are you guys good with that? I'm also going to have, it's going to be the same thing for the other one, right? Yes? It's the same volume, same molarity, right? So I also have 0.02 moles of MgNO3 parentheses 2. For every one of these, I need double of these. So for every one of these, I need double of those. Do I have double of this? No, therefore this is my limiting reactant. Good? Micah, you good with that? So I'm going to run that to grams. So 0.02 moles of KOH times 1 mole of KOH high. Here you go.
Okay.
Is, what was that, 58?
Wait, I thought it was 2 moles of KOH. Wait, oh no. Wait, where are we?
Because I'm just running this to grams.
Okay, I did it wrong.
What?
Nothing, I did it wrong.
Are you sure?
Yeah.
Okay.
There's 2 KOHs, so do we ever include the 2 in there? And like
Only if I was going to be doing a stoic step.
Okay.
There's not really a stoic step here. I'm not going between two different things.
That's what I did.
Okay? So 1 mole of KOH is 58.33 grams of KOH. So 0.02 times 58.33. I got 1.16 grams. So this is 1.1, I guess technically 7 grams of KOH. So that was C. And then D, calculate the concentration of each ion remaining in the solution after precipitation is complete. It's probably good that we're doing one of these, in all honesty. So now I've got to do my net ionic equation, right? So here's my balanced. So that's going to split into 2K plus 2 OH minus, let me know if you have questions, plus Mg plus 2 plus 2NO3 minus. Any questions on the left side of how I split that up and why this is what it is? No. Okay. On the right, I'm going to have 2K plus 2NO3 minus plus my precipitate MgOH parentheses 2. So my spectators are 2Ks, 2NO3s, 2NO3s, and which other one am I going to have to calculate the concentration of? There's one other ion I'm going to have to calculate the concentration of. Which one is it? Is it OH or is it Mg? It's Mg. Why? Because OH is getting all used up. Why? Because OH is part of my limiting reactant. So this one is in excess. So I have 3 ions I've got to calculate the molarity of. I'm actually surprised first period didn't ask for this. So here we go. So let's start out with potassium. So potassium, we know that molarity is equal to number of moles per liter. So that is equal to, for potassium, I have 0.02 moles divided by what liters for that? What's my liters going to be?
Wait, 1.
1?
Point
0.1 plus 0.1,
Wait, 2.
right?
Wait, why is it point? Why are we adding 1?
Because I have to add them together. Add them together.
Add what together?
On 67, I've got 100 milliliters added to 100 milliliters.
Okay.
So that's a total of 200 milliliters.
Point 2.
So it's divided by 0.2 liters. So that's easy. So 0.02 divided by 2. My answer is 0.01 molar of, what was that for? K plus. K plus. Are we good so far? Yes?
Why did you do that again? Sorry.
Add, because on, it's 100 milliliters is mixed with 100 milliliters. So you have to add those two together. 100 plus 100 is 200. Yes? The other one is going to be NO3. So NO3, I have 0.02 moles times what? 2. Because there's 2. So that's going to be 0.02 moles times 2 divided by 0.2 liters. So 0.02 times 2 equals, divided by 2, that's going to be 0.02 molar of NO3 minus. So there's 1, there's 2. Are we good so far?
I have a quick question.
Yes.
Okay, so back to part C, when we determined that like 0.02 moles of KOH and then also 0.02 moles of MgNO3, why are they both the same amount?
On where?
For part C, with the limiting reaction.
Because they were both going to be, because they were both 100 milliliters and 0.2 molar.
Okay. Okay.
So it's going to be the same amount of moles.
Okay. Even. Okay. Thank you.
Because it's the same molarity, same amount of moles.
I see. I see. So we would have to look back to like the question.
Correct.
Okay. I see.
Yes.
Thank you.
So now I have to figure out what is my excess. So I'm going to take my limiting reactant, which is still KOH. So, and then I'm going to run that to my liters of what? Moles of Mg, right? So here we go. So I have 0.02. Is it 0.02? Yes. So 0.02 moles of KOH times, here's my stoich step, right? For every 2 moles of KOH, am I still up here? Yep. I have, sorry, 1 mole of, I'm going to Mg, right? MgNO3. So, I'm trying to think, is that the last step? Because we need moles per liter, right? This would be how much is used. Moles. Yeah, I think we're good. So 0.02 divided by 2, that means 0.01 moles of MgNO3 were used. Are we good with that? How much did I start with? 0.02. So I've got to do 0.02 minus 0.01, which is what? 0.01 moles of MgNO3 excess. So that's a 1-to-1. So I'm going to take 0.01 moles divided by 0.2 liters, and that gives me 0.01 divided by 0.2, 0.05 molar Mg plus 2. I'm really glad you guys asked that one. Now, we didn't finish it, but if I was writing my net ionic equation for this, I'm going to write it up here. My net ionic equation would have been 2 OH minus plus Mg plus 2 yields MgOH2. 2 negative plus 2 positive is what? 0. 0 on the left, 0 on the right. There should not be charges in this compound. Yes?
Okay, sorry. I just had a question. Okay, so at the very end when we're doing 0.03 mole KOH to that whatever.
Yes.
Why don't we go again like further and do like 1 mole of MgNO3 is equal to this many grams? Why don't we go there?
Because we don't need grams, we need moles.
I see.
Because we need molarity.
Okay.
So grams isn't super helpful to us.
Okay. Thank you.
Okay. So that was 63. 7. Thank you for whoever asked that because that was a really good one to do. What?
There's Adrian. Cat.
Great job. Great job.
Okay, so the 69, is that similar to the one we just did? I had that one.
What number?
I had one more for you.
I'll check in a second.
You guys are 45 and 47.
What number are we doing next? After 67, 69. Here we go. Oh, shoot, guys. Look what number we just did. 67. How do we miss that? I know, but like, we can't miss that opportunity. Like, that's a missed opportunity. 69. So, a 1.42 sample of a pure compound. Okay, it's one of these, right? It's one of these where we don't know what the compound is. With a formula of M2SO4 was dissolved in water and treated with an excess of aqueous calcium chloride, resulting in the precipitation of all the sulfate ions as calcium sulfate. The precipitate was collected, dried, and found to weigh 1.36 grams. Determine the atomic mass of M and identify M. Okay. Step 1 is going to be what?
Okay, first step.
What?
Making the equation.
Write the balanced equation. So, balanced equation. I have M2SO4. It tells me that that is aqueous, right? Because it said it was dissolved in water. What am I adding to that? CaCl2. We know that is also aqueous from the back of our blue sheet. So that's going to give me CaSO4. Somebody tell me, is that aqueous or not?
It's a solid.
That's the solid. That's not soluble. Plus MCl. Are you guys okay with how we just did that? Yes, Kayusa. It is. That's why I got the down arrow. There's not soluble. Balance it. 2 here. I think that's it. Right? So they tell me that I have 1.42 grams of this. They also tell me that I have 1.36 grams of this. Right? Determine the atomic mass of M and identify M. So this is really not too bad because they're giving me a number to start with. So I'm going to start with my 1.36 grams of CaSO4. So CaSO4 molar mass is 136.15 grams of CaSO4 in 1 mole of CaSO4. It's a 1-to-1. For every 1 mole of CaSO4, I have 1 mole of M2SO4. So this gives me, when I solved mine out, I got 9.99 times 10 to the negative second moles of M2SO4. We know that molar mass is equal to grams per mole. Do I have a gram amount? Yes. Sure do. So it's going to be 1.42 grams of M divided by 9.99 times 10 to the negative second moles of M. And by M, I mean M2SO4. M2SO4. Did anybody get this far? What'd you get?
142.14.
That's what I got. I got 142 grams per mole. 142 grams per mole. Am I done? No. Why? Because that's the molar mass of the whole compound. Right? So now I got to figure out what's M. So that's the last step. So I'm going to take my 142. I'm going to subtract, what's oxygen's rough molar mass? 16. So minus 16 times 4 minus, what is the rough mass of sulfur? 32. When you subtract that, you get 46 grams of M. But how many M do I have? So divide that by 2, which equals 23 grams per mole, which is equal to what element? Sodium. Equal to sodium.
It's not magnesium.
It is not magnesium. Because sodium is 22.9.
They pranked us. Wait, why? So then what? I don't see any sodium.
Huh?
They had it wrong.
The M2, this we're saying that M2 was sodium. We were trying to determine M was the unknown.
M is like a variable.
Right, M is a variable. We were trying to solve for it. So, a mass of 23 is sodium.
It was just a little bit confusing because it looks like it would be like element.
M as a variable.
Why M? Because there's no element M. There is no element M, that's why. They could have used X or Y, you're right. There is Y, that's like uridium.
Yeah, we asked you this question and you never answered.
We're gonna have to get to that. We don't have time today.
The man is.
Are you guys okay with that? That was 69. Any other ones? Yes.
Okay, this is an easy one. Can we do 31?
Sure. All right, 31C. It's a good one to do.
Dover won because they played Queens.
What are we talking about back there, Arch?
Yes, that's what I need.
Battle of the Bands.
We're talking about football?
Band.
Band?
Archie's dogging on the Woo band right now.
You cannot be dogging on the Woo band.
They started dogging on the football team first.
We haven't won.
How many games has the Woo band lost?
Thank you, bro.
New Philly dusted them.
Nuh-uh.
Yes, they
Stop hating on our band, dog.
Nobody should be comparing bands. All right?
Dover
Just
band
because
was
one band is good doesn't mean they're
Ours
better.
is still better. Dover's band
I mean, I'm not gonna lie. I think Dover probably is better than our band.
Wow.
They were hitting dance moves. Did you see them out there?
Yeah, hold on. Dover one's pretty solid, though.
I mean, their whole band was dancing. I hate
Yeah, they.
All right, here we go. 31C, here's how I do it. I have 0.1025 grams of copper.
So it's not Cu2 plus yet?
Just copper. Not copper ion, copper metal.
Okay.
Times, copper is what? 63.55, close enough, grams of copper in 1 mole of copper. So if I do my math, 0.1025 divided by 63.55, that's small. 0.00161, is that what you guys got?
Yeah.
Moles of copper. Divided by?
0.8.
No.
So would it be like 2
0.035 liters.
Where are we getting that from? Huh?
Because it was dissolved in 35 milliliters. Oh, wait, hold on. Pause. That's not water. Pause.
You're like, Sarah, you're right. It is.
Okay, so there's my moles of copper. There's my moles of copper. Wow, I got ahead of myself. Stay calm.
Oh my.
So now I have 0.035 liters of HNO3. Of HNO3. Do they give me a molarity of that? Calculate the molarity of Cu. Okay. So I've got, before we do this, let's write a balanced equation. Copper plus HNO3
I brought no clean clothes. Or,
That's right.
so I have no clean clothes.
We got no clean clothes. I thought we were talking about. You're talking about those are the strong or weak acids, which you got to know.
It dissolves.
You got to know strong or weak acids for tomorrow.
Okay, wait.
You got to memorize those strong acids. So I brought no clean clothes. Okay. All right. So this is going to give me H2 plus CuNO3 parentheses 2. Put a 2 there. That's balanced. So now I've got a balanced equation. Are we still together? No? Why?
We're apart. How did we go from liters?
Well, I just said we should probably write a balanced equation.
I see. Okay.
We got ahead of ourselves.
Is that
So, I have moles of copper. Are we good with that? This would also be equal to 0.00161 moles of Cu plus 2. You guys would agree those are the same thing, right? Yes? Changing the number of electrons doesn't change your number of moles. It just changes your charge. You guys good with that? Okay. So, I think I made this harder than we needed to. Because 31 is asking us for the molarity of Cu. Oh, we don't really care about the other thing, do we? So I would just take your moles and divide it by what? Liters. What's my liters?
200 milliliters.
200 milliliters, which is 0.2 liters.
You said point, wait, it's gonna be point.
0.2 liters.
Okay, so it's 0.2 liters, same difference. Wait, no, I made the wrong one, sorry.
So 0.00161 divided by 0.2, I get 0.00805. So that's equal to, forget all this nonsense, forget this nonsense. That gives me 0.00805 molar of Cu plus 2. That was it. So he doesn't solve for moles, divide by liters.
Wait, so why did they give us the point oh? Yeah.
Why? Distraction. We got pranked. I got pranked. What? Yes. What else? Anything else? So, what's going to be on the test tomorrow? Equations. Strong and weak acids. Balancing by the half reaction method.
What?
Balancing by the half reaction method, you know, how many lost, how many gained,
Okay, wait.
right? What's oxidized, redox, what's reduced. Net ionic equations is going to be on there. And you know there's going to be some kind of lab procedure, right? There's going to be some kind of lab procedure question where I'm like, how would you make this molarity of something? Think about what we did over in the lab.
Can I use my
What?
Can I use my lab papers?
No.
So you said it'll be redox net ionic lab procedure.
Redox, net ionic, basic molarity, all remaining ions concentration, like we just did. Yeah, it's a pretty straightforward test.
Are they gonna be as long as 6 or 7 foot?
There'll probably be one like that.
I really don't understand that.
Let's not
Oh,
do
we
that.
did those.
One like 6, 7.
Like 6, 7,
There is one like that?
probably one.
You said there was a tiny bit last time, and there was one that was good.
I'm not saying what is or what's on the test, okay? No.
Well, make sure you don't.
I'm just saying what is fair game, which is everything.
What do you say?
I'm saying what's fair game, which is everything. Oil rig. Yep, there you go.
What? Stop with these acronyms. Snaps?
Snaps.
Wait, oxidation is losing.
Is
Reduction is
production.
gaining.
But you really don't have to memorize snaps because you have the back of your blue periodic table for that.
It's not.
Now for the AP test, you don't need to know that.
What's soluble?
What's soluble? What's soluble?
Wait, so what is it?